Hi, welcome back. We're going to finish page 30 of the homework, and we just finished off talking about these unique spaces. Well, notice they're wanting us to see that the unique spaces are actually triangles inside these shapes. So this made one triangle, because it's a triangle. This ended up making two triangles. 1, 2, 3 triangles. And then 1, 2, 3, 4 triangles. So they're saying, could I say if I had a shape that comes next, if this is in, would I be able to predict, not knowing how many sides it has, it's just kind of a blobby looking thing off to the side, right? Could I predict the number of triangles in here? So I'm thinking I see a pattern. If I have 3 points or 3 sides, I have 1 triangle. 4, I have 2. 5, I have 3 triangles. 6, I have 4. Hopefully you're noticing that this would be n minus 2. So that's my conjecture, that my number of triangles are n minus 2. Whatever the number of sides I have, or whatever the number of vertexes I have, minus 2. Hopefully you're seeing that pattern. If not, you feel free to, we'll discuss it a little further. Okay, next question. This one's like the one in example 3, so make sure you're using your book or your notes from today, and we're going to find out the pattern between the number of seniors and the seniors who have a driver's license. Okay, so let's see if we can find a pattern. And you may need a little help from your book, so don't forget to use your book if you checked one out. So this picture in the book. Okay, so here's the example in the book. And it looks like, let's see what they did here. It looks like they took the number of voters over the total residents, the number of voters over the total residents, the number of voters over the total residents, and they noticed that it looked like about 12% of people, not exactly, but about, that means about 12% of the voters looking for that pattern by comparing these. So let's do something similar. The table shows the number of students in the senior class and the number of seniors who have their driving license. So let's figure out what percent of seniors have their driver's license. Okay, so I think we could say 22 out of a total of 341 seniors have a driver's license. Let's see what percent that is. Make sure you can see it here. Okay, so I get about 65%, so more than half. And let me try this next one. 240 out of 367. Ooh, pretty close. So that'd be 65% again. Pretty close. Okay, let's do another one. 199 out of 309. 64, but that's pretty close. So what pattern can you find? About 65% of seniors have their driver's license. Okay. Next one, the class of 2018. Ooh, so what if the number of seniors in 2018 had 413 seniors? Would we be able to figure out how many had their driver's license? So I'm going to put X because we don't know what that is. Now we kind of know though, because we know that X, the number of seniors with license over 413, should equal about 0.65. So we can use algebra to, if we multiply both sides by 413, we should be able to solve for X. So 413, 413, that cancels, and x is about 65% times 413. I get 268.45. We can't have a fraction of a person, so my guess would be about 268 seniors. Maybe you would want to round up, round down. I'm okay with either one. All right, now we get into this counterexample. So that's pretty cool. We didn't really talk about this today, depending on the class, but I can read example 4 in my textbook. And a counterexample sounds just like that. It means find a reason, find a way to prove me wrong. Find a way to prove me wrong. Okay, so a trapezoid cannot have more than one right angle. So let's draw a trapezoid. That's like your desk. So this is a trapezoid. By definition, if you Google it, so I would suggest Googling, it'll say one set of parallel lines. So this is one set of parallel lines. This is parallel to that. So technically, to be a trapezoid, you only need one set of parallel lines. Now the problem is, if it has a trapezoid cannot have more than one right angle. Oops, this looks like I have two right angles. So this picture proved you wrong, proved this person wrong. If you Google pictures of trapezoids, you will find an example of this one, because by definition, a trapezoid is a four-sided shape that has one set of parallel lines. I can, this is wrong because I can have a trapezoid with two right angles. Cool. Okay, now it says, support the following conjecture with 4 examples or disprove it with a counterexample. So let's say I believed this is true, then I should come up with 4 pictures showing, yep, it's true, and I like it, and I'm good. Okay? So that's what they're looking for here. Let's see if we can make sense of this. Number 16 says, the quotient of 2 rational numbers is a rational number. Okay, so you could probably Google this and see if you get anywhere with it. The quotient means to divide. So sum means to add, difference means to subtract, quotient means to divide. So 2 rational numbers. You could Google this as well. You can also look it up in your book in the glossary. So maybe we'll do that. But I know that this number is rational and that number is rational. The quotient of 2 rational numbers is a rational number. Would we say this is a rational number? If 3 is rational and 4 is rational, is the number 3 over 4 rational? Now we don't, again, this is just kind of going through logic. A lot of this stuff won't necessarily be on a geometry test, but at the beginning of a book, we think about our thinking. So let's look up rational in the back of our book. We have one, or just Google it. And look, rational. It's not even there. So the reason why it's not there is this is more of an algebra concept, but we will use it. So if I Google what rational is, you'll probably get something. Let me go ahead and Google it. Hold on one second, because I'm taping on my phone, so I can't Google it on my phone and videotape at the same time. So just give me a second. Now you might want to Google rational number. So Google rational number. Okay. So it says 1/2 is rational. 1 divided by 2 is rational, the ratio 1/a. So the definition of rational, it says, is if a number can be made by dividing 2 integers. Okay, so they gave the example, a rational number is a over b, where this has to be an integer and this has to be an integer. That's a whole number, but it can be positive or negative. Hopefully that's helpful. A number that can be made by dividing 2 integers. Okay, so a quotient of 2 rational numbers is a rational number. I think I'm going to come up with a counter example. The reason I'm not going to come up with 4 examples because I can already think of a way to disprove it, kind of like I disproved this one. Let's see if this makes sense. A quotient of 2 rational numbers. So we already know that 3/4 is rational because it could be set up an integer over an integer. So this would be an example that works. This one works, but a counter example is where it's wrong or it doesn't work. So we know the number 3/4 is rational because it can be set up like that. So let's take 3/4. But then what they're saying is, can I take a rational number and then divide it by another rational number? So think of another rational number, maybe 7/8. Can we take a rational number and make a quotient or divide it by another rational number and get a rational number? Get a number that's an integer over an integer. My number one problem is this is not an integer. So because that's not an integer, by the definition of rational, I'm not getting the definition. This has to be an integer, and that is not an integer. They said I could take any 2 rational numbers. So my counterexample shows my disapproval. Thanks for joining us.